So let's make the this first week of our second semester productive. No, let's discuss the first lesson in data structures and algorithms. I hope that we are clear with regard to our orientation, especially the class policy, our program and course intended learning outcomes. So if you have further questions regarding that, don't hesitate to ask. No, for the first lesson, this is all about data structures and algorithm overview. Okay, so let's move on to the lesson objectives. For this lesson, we are expected to define and understand data structures and algorithm terminologies, understand the data structures foundation of terms, identify the characteristics of data structure, identify the characteristics of algorithm, identify or learn the basics of algorithm, and of course learn how to write an algorithm. So we are expected also to create like to solve a problem or create an algorithm in solving a problem rather. Data structure overview. So, just to share with you guys, according to programmings.com, a data structure is a named location that can be used to store and organize data. And an algorithm is a collection of steps to solve a particular problem. Well, when combining them two, and learning data structures and algorithms, it allow us to write efficient and optimized computer programs. So we can make a better program structure. To further discuss what is data structure, study of various ways of organizing data in a computer. This is also a programmatic way of storing data so that data can be used efficiently. And also, it is a systematic way to organize data in order to use it efficiently. This is actually according from tutorials.com or nw3schools.com. So, we can say that a computer program is a collection of instructions to perform a specific task. Now, for this, a computer program may need to store that data, retrieve the data, and perform computations on the data. That's why we need to understand this. Why do you think that data structures and algorithm is important to learn, especially for you, no, guys, as a student? Okay, the reason of learning about data structures is because adding structure to our data can make the algorithm much simpler, easier to maintain, and often faster. Please take note that programs are comprised of two things. So, yun yung data that we are putting into our program and the algorithm or set of instructions. Well, our data is information processed or stored by a computer, and the algorithms describe the way or how the data is being transformed. So, in a nutshell, data and structure is really an important data structure and algorithm is really an important factor for us to make um, a complex and hard kind of program into an easier one to make it more simple and easy to understand. The next thing that we are going to discuss is the foundation terms of data structure. So we actually have two, the interface and the implementation. So we will be discussing one by one. When we say interface, it represents the set of operations that a data structure support. Well, an interface only provides the list of supported operations, types of parameters that they can accept and return type of this kind of operations. While the implementation provides the internal representation of a data structure. Implementation also provides the definition of the algorithms used in operations of the data structure. So again, to have a quick recap, interface are sets of operations that a data structure supports, while implementation provides the internal representation of a data structure. Next, what are the characteristics of data structure? So, most commonly, meron tayong tatlo. But marami pa yan, pero ito yung most common and important ones. So, we have the correctness, time complexity, and space complexity. Later on, we'll talk more about the time and space complexity to understand it better. But to have a recap, or not really a recap, rather, to have a review or overview of these three characteristics. When we say correctness, your data structure implementation should implement its interface correctly. So from the word itself. So dapat tama siya na ma-implement. Then yung time complexity naman natin is the running time or the execution time of operations of data structure must be as small as possible. Bakit po ganoon? Kailangan na mas maiksi yung running time or execution time. So, kapag mas maiksi po ang running time or execution time, then the return of the output is also fast. Space complexity. Memory usage of data structure operation should be as little as possible. We know that most of our programs are created for devices like on-the-go applications, no? For example, on our devices like mobile phones, marami tayong ginagamit dito na different kinds of applications to support the different tasks that we do every day. So, as you can see, our mobile devices is a very limited option in terms of memory. So, if we do have applications that has little memory allocation, then it would work best with devices that are just, small, like mobile devices. So, parang in a way, ang gusto natin is makapag-create tayo ng mga programs na as compact as possible so it can actually run on different platforms no matter how big or small your device is. So, yun po yung different characteristics of our data structure. So, once again, just a quick recap. Those are correctness. Your data structure should be implemented correctly. Time complexity. The data structure must be as small as possible. And space complexity. The structure of the operation should be as little as possible. So, yun po yung ating characteristics of data structures. Now, let us understand better why there is a need for data structure. So, most likely, we wanted to consider or to do a lot of things on the web, even on our devices. So, these are the following reasons why we need to create a good, not good, but the most appropriate data structure for a program. So, first one is data search. Let's consider an inventory of 1 million items of a store, no? Lalo na, for example, kung ikaw ay starting business pa lang. If your application is to search an item, so let's say you created a program for you to make an inventory of your different items, and let's say meron ka ng 1 million na different kinds of goods or products. If your application is to search for an item, then it has to search an item in 1 million items every time. No, it is possible that the operation may take time because you already have a very large data. So what will happen? It's gonna slow down the searching operation because as data grows, searching will become slower. So, yun yung mga common problems that we experience in database management. So aside from that, the processor speed. So, for example, even though the processor of your device is very high, it might fall, or most likely it falls limited if the data grows to be billion of records. Kaya nga, for example, kahit na nga lang sa pagpili ng specifications ng mobile phone, ng laptops, kahit gaano pa kabilis yung processor speed na kinuha mo during the time that you purchase an item, as the moment goes by, when you added programs, you added different files, and technically you're just putting more and more data into your device, your record will grow. It will start from one up to hundreds, thousands, up to billions of records. Now, kahit gaano pa kabilis yung processor mo, but since the records are growing, it will still affect the the speed and the process of, let's say, searching the data on your storage. So for example naman, if you have multiple requests, no, parang dun sa mga e-commerce applications or websites natin, if there are thousands of users that are searching data simultaneously on a web server, imagine you are searching for a specific kind of product, and you're not the only one doing that. So siguro marami pang nagre-request ng information na katulad mo sa buong mundo. And then if these people are doing that at the same time, even the fast server fails while searching the data. Kaya nga kung minsan mapapansin nyo kapag parang naglalag yung pagre-return ng information back to you, then it's probably because there are a lot of people requesting the same information at the same time. Maybe not exactly the same, but you are requesting different kinds of information at the same time would still affect the return of the information that you are looking for. Now, to solve the mentioned problems that I have told you, data structures come to the rescue. Kaya nga meron tayong pangangailangan talaga sa data structure, because data can be organized in a data structure in such a way that all items may not be required to be searched, and the required data can be searched almost instantly. So in a way, napakadaling intindihin, we can organize the data that we will be sending to the people who needs it as soon as possible, and then just keep like a couple of minutes or time for those people whose request is not that important or not needed badly. So, yun yung ilan sa mga reasons kung bakit ba talaga kailangan ng data structure. So, as we progress on the lesson, we'll definitely understand better why data structures and algorithms go hand in hand. On the next slide, we will be talking about the different types of data structures. So, basically, we have two. Meron tayong linear data structure and the non-linear data structures. So let's discuss first the linear data structures. The elements are actually arranged in sequence, one after the other. That's why it's called linear. Now, since the elements are arranged in particular order, they are easy to implement. So it's just like following a certain number of steps. However, when the complexity of the program increases, the linear data structures might not be the best choice because of operational complexities. So parang the more requests, the more process that the structure are needed to be done might be complex already, and linear data structure is not the best option for that kind of transaction. The second one is the nonlinear data structures. So unlike the linear, elements in nonlinear data structures are not in any sequence. So instead, they are arranged in a hierarchical manner where one element will be connected to one or more elements. So ito naman yung solution for complex operations. Parang hindi na sila sinusunod one by one or step 1, step 2, step 3 because they are connected from one operations to another. So, parang in a way, may different nodes and then that node is interconnected to different other nodes. So, mamaya i-discuss pa natin yan. Let's just take a look on the different popular linear data structures. So, ito yung idea natin, no? Kaya nga tinawag natin linear data structure. So, there are actually four popular linear data structures. Hindi lang ito yon pero marami pang iba. So, yung nilagay lang natin is the most common and popular. Ito yung array data structure. So, as you can see, parang example natin dito, in an array, elements in memory are arranged in continuous memory. So, all the elements of an array are of the same type. So, if it's an integer, it should be an integer. If it's a string, they should be all string arrays. And that type of elements can be stored in form of arrays, which is determined by the programming language that you are going to use. So, for this example, an array with each element represented by index. Ito yung value natin, 215434. That's the content of our array, probably an integer because it doesn't have a decimal place. And then this is the index number. So, the index number actually tells us the location of that element. So, of course, we are going to talk about all of this once we go to the to creating arrays using data structure. So next, we also have the stack data structure. So on this example, in a stack data structure, elements are stored in the LIFO or LIFO principle. If you remember, LIFO principle is last in, first out principle. So that is the last element stored in a stack will be removed first. So if you entered 3 as the last element, once it has been removed for the allocation, the first or the last in element will be the one to go out of the stack. So it works just like a pile of plates, no? Where the last plate kept on the pile will be removed first, or in a stack, operations can be performed only from one end or the top. And on this case, on the top of the stack. Parang, ayun nga, last in, first out. So the other example of linear data structure is yung queue data structure. So, sa queue data structure naman, unlike stack, the previous one, the queue data structure works in the FIFO principle. So, kung kanina last in, first out, ngayon, first in, first out principle, where the first element stored in data structures will be removed first. It works just like a queue of people in the ticket counter. Now, for example, when you're buying at a Jollibee or McDo fast food chain, you will be the first one or the first person on the queue who will be served first by the cashier. So, in a queue, this example that is showing here, addition and removal are performed from separate ends. The next and the last but not the least popular linear data structures that we are going to discuss is the linked list data structure. So for the linked list, as you can see on the example, we are actually the data elements rather are connected through a series of nodes. No? So, ito yung first node natin, second node, and the third node. Each node contains the data items and it's being addressed to the following node. So, it's, well, technically, if you take a look at it, it's almost the same as the array data structure, except that instead of using array, you are using nodes to store the data elements, and one node is connected to another node. So again, those are the four popular linear data structures that you can use. Meron tayong again, the array data structure, stack data structure, queue data structure, and the linked list data structures. So now that we are done discussing the popular linear data structure, the next thing that we will be talking about are the examples that we can use for non-linear data structures. So most likely ito na yung ginagamit talaga for complex kinds of instructions and operations. So, yung meron tayo normally is the graph data structure and the trees data structure. Um, Non-linear data structures are actually divided into these two, the graph and the tree-based data structure. So, in graph data structure, each node, ito yung example natin. So, meron tayong 0, 1, 2, 3, and 4. Each node is called vertex. And each vertex is connected to other vertices through the edges. So, as you can see, the 0 vertex is connected to vertex 1, vertex 2, and vertex 3. Unlike the linear, which you are just following like step 1, 2, 3, 4, and 5, in this case, since we are using graphical data structure, all of the vertices may be interconnected among each other through its edges. So, merong ilang popular graph-based data structures. Actually, marami to. So, once we go to the graph-based topic, siguro discuss natin to doon ng mas detalyado. So, meron tayong spanning tree and minimum spanning tree, graph-based data structure, meron din tayong strongly connected components, meron tayong adjacency matrix, adjacency list. So, ilan yun sa mga graph data structure. Yun namang tinatawag nating trees data structure. As you can see on the example, is just like a family tree. Similar to a graph, a tree is also a collection of vertices and edges. However, in data structure, there can only be one edge between two vertices. So, at most, you can have like adjacent vertices, up to 2 adjacent vertices per node. So, dito katulad nito, si number 1 hanggang 2 lang siya. Unlike here, dito si number 0 node can be connected to more than 2. So, that's actually the difference between the two. So, meron tayong ilang popular tree-based data structure. Meron tayong binary tree, binary search tree, ABL tree, B-tree, B+tree, red black tree, and so on. So, again, we will talk more about those once we go to trees lesson. Now, in a nutshell, since we already know what linear and nonlinear data structure is, let us summarize the difference or the comparison between the two. In linear data structure, the data items are arranged in sequential order, one after the other, while in the nonlinear data structure, the items are arranged in non-sequential order but using a hierarchical manner. In linear data structure, all the items are present on the single layer, while the nonlinear data structures, the data items are present at different layers. So, in addition to that, in linear, it can be traversed on a single run. That is, if we start from the first element, we can traverse all the elements sequentially in a single pass. However, in nonlinear, it requires multiple runs. That is, if we start from the first element, it might not be possible to traverse all the elements in a single pass because you have to run it multiple times. The memory utilization in linear data structure is not efficient, while in nonlinear data structure, the different structures utilize memory in different efficient ways depending on the node of the operation. So, sa linear data structure, the time complexity increase with the data size. Meaning, kapag mas malaki yung data size mo, the time complexity is also increasing, while in the nonlinear, time complexity remains the same. So, for example, ang linear are arrays, stack, and queue. Example naman ng non-linear are tree, graph, and map. So, yun po yung pagkakaiba, advantage and disadvantage of the linear and nonlinear data structures. Let's move on to the next slide. So this time we are going to talk about the different execution time cases. A while ago, we are talking about like the running time, gaano kabilis, gaano katagal, dapat matapos ma-process or ma-execute ang isang data. Now, there are three cases which are usually used to compare various data structures' execution time in a relative manner. The first one is the worst case. This is the scenario where a particular data structure operations takes maximum time it can take. No? So again, in the worst case, the data structure operations takes the maximum time it can take. So if an operation worst case time is Fn, then this operation will not take more than Fn time. When we refer to Fn, we are talking about it represents the function of n. So again, for example, sabi nga dito, if the operation's worst case time is, let's say, 1 minute, then the operation will not take more than 1 minute. But it's going to maximize the 1 minute time allotted to the operation. Next, the average case. This is the scenario depicting the average execution time of an operation of a data structure. So, for example, if an operation takes the function of n time in execution, then the minimum operations will take minimum functions of n time. For example, the operation allotment may take up to 1 minute. However, the average case is that it will only take the minimum time that the what do you call this? The minimum time that the operation must be finished. For example, in 30 seconds, dapat ay tapos na ito. That's the minimum time requirement. Then, that's the average case because it will take the minimum time requirement. So, unlike the worst case, it will take the most even beyond the maximum time it can take. Well, the best case is that if the scenario depicting the least possible execution time of an operation of a data structure. So, we can say that the best case would just take the time execution. The actual operation may take as the random number which would be maximum. Parang in a way, kung kaya na niyang tapusin in just 3 seconds pa lang, kahit the minimum time is up to 30 seconds and the maximum time is to 1 minute, the operation may already be done in just 3 seconds. So that's considered as the best case. Now, apart from the execution time cases, we will be talking about why do we actually need to learn data structure and algorithms. But before we go ahead and do that, I'd like to discuss to you, or to have a quick recap rather, of the execution time cases. So again, for the worst case, this is the scenario where a particular data structure operations takes maximum time it can take. For the average case, this is the scenario depicting the average execution time of an operation of a data structure. While the best case is that this is the scenario depicting the least possible execution time of an operation of a data structure. So now, let's move forward to why do we really need to learn data structures and algorithms. And after this, we are going to discuss the basic of an algorithm. So now on this section, we will learn why every programmer should learn data structures and algorithms with the help of examples. This section as well are for those who have just started learning algorithms and wondered how impactful it will be to boost their career in programming skills. It is also for those who wonder why big companies like Google, Facebook, and Amazon hire programmers who are exceptionally good at optimizing algorithms. So yes, these big companies are actually in making an investment to people who can um, optimize all algorithms for their operations, because it really is going to affect their daily operations if they have an optimized algorithm. So let us discuss further what is an algorithm. So informally, an algorithm is nothing but a mention of steps to solve a problem. They are essentially a solution. Like for example, an algorithm to solve the problem of factorials might look something like this. So the problem is find the factorial of n. So as you can see, the solution can be somehow like this. It's actually an algorithm only. Initialized factorial is equals to 1 for every value in range 1 to n. Multiply the factorial by value, and then the factorial contains the factorial of n. That's the result of your factorial. Now, here, as you can see, the algorithm is written in English. If it was written in a programming language, we would call it a code already. So again, this is just an algorithm. It's just like an English sentence. Kapag ka naging code na siya, then, kapag ka nakasulat na siya as a form of programming language, then it's already a code. Programming is all about data structures and algorithms. So, well, data structures are used to hold data, while algorithms are used to solve the problems using that data. We can also say that data structures and algorithms goes through solutions to standard problems in detail, and it will give you an insight into how efficient it is to use each one of them. Well, it also teaches you the science of evaluating the efficiency of an algorithm, and will enable you to choose the best of various choices. So, yun naman lang yung talagang pinaka reasons why algorithm is really important. Let us discuss the categories of algorithms. Meron tayong 5 categories listed here. So, yung ating search, sort, insert, update, and delete. So again, no, just a quick recap. Algorithm is a step-by-step procedure. So it defines a set of instructions to be executed in a certain order to get the desired output. Algorithms are generally created independent of underlying languages, so it doesn't really matter if you are using Java, C++, Perl, Ruby, Python. It's just like a solution. Algorithm is also a solution to a specific problem. So, for example, an algorithm can be implemented in more than one programming language. So, it's not dependable on a specific language alone. Now, from the data structure point of view, these categories that are shown on the screen are some of the important categories of algorithms. For search, algorithm to search an item in a data structure. So, pwede ka daw gumawa ng algorithm to search an item. You can also create an algorithm an items, to sort items in a certain order. You can also create an algorithm to insert item in a data structure. You can create an algorithm to update an existing item in a data structure and create an algorithm to delete an existing items from a data structure. So again, these are just some of the important categories of algorithms in its data structure point of view. So once we're able to discuss some of the important matters here, we will also discuss like a couple of algorithms in sorting, searching, and so on. If there are categories of algorithms, there are also characteristics of an algorithm. So what are those characteristics? We have the unambiguous characteristic. So, well, before we discuss those, not all procedures can be called an algorithm, no? Just to clarify. Again, not all procedures can be called algorithm. An algorithm must have these characteristics for them to be called an algo. So again, number one, unambiguous. Your algorithm is unambiguous because it should be excuse me, it should be clear. Each of the steps that you're going to create, the inputs and outputs should be clear and must lead to only one meaning. So you have to be specific because you don't want to create an algorithm that's very general. Next, the input of your algorithm should have zero or more well-defined inputs, while the output of your algorithm should have one or more well-defined outputs, and of course, it should match your desired output. Kung ano yung goal mo in creating this algorithm, the output should match that goal. Your algorithm must be finite or finite. You can use either of the two. It must be finite because it must be terminated after a finite number of steps. Hindi pwedeng tuloy-tuloy lang ang isang algo. Meron siyang finite number of steps and should have at least one output. The next is that your algorithm should be feasible with all available resources. So meaning the inputs that you need must be available to say that it is feasible. Kapag hindi available yung mga kinakailangan mong resources, yung mga input mo, then it's actually not feasible at all. So therefore, hindi daw siya isang algorithm if the resources or the input is not available to the user. And lastly, your algorithm should be independent. Just like what I have mentioned a while ago, an algorithm is not dependent to a specific programming language. So meaning avoid using keywords that are only known to a specific programming language. As much as possible, do not use jargon terms that are only available to a specific language. Kailangan ay siya ay universal language, meaning pwedeng maintindihan ng kahit sino. Kahit ano pang programming language ang gamitin niya, pwede niyang i-apply yon. So those are the characteristics of an algorithm. Without the six, without your algorithm being unambiguous, simple and clear, and only leads to one meaning without its input, at least none to more defined or well-defined input and output, at least one output and more or more, but it should match the desired output. It should be finite with only a finite number of steps. It must be terminated at the end, and that the resources or inputs should be available to make it feasible, and the algorithm should have a step-by-step directions and not dependent to a specific programming code. So yun po yung ating characteristics of an algorithm. Now, let's proceed to how do we actually write an algorithm. So, we write algorithm in a step-by-step manner, just like the what we were talking about a while ago, but it is not always the case. Well, algorithm writing is a process and is executed after the problem domain is well defined. That is, we should know the problem domain for which we are designing a solution. Just like a scientific problem now, if before you can actually create a solution for that, you must know what is the problem to be solved. In fact, there are no well-defined standards for writing algorithms. Wala tayong sinusunod na standard doon. Rather, it is a problem and a resource dependent because algorithms are never written to support a particular programming code. As we know that all programming languages share basic code like constructs such as loop, do while, for while, mga flow control katulad ng if, else, etc. These common constructs can be used to write an algorithm. Pwede naman yun kapag mga common. Pero kapag specific to parang keyword to a specific language, then avoid using those kind of words. So, bigay tayo ng ilan sa mga common or parang everyday na ginagawa natin. Example lang, an analogy of an algorithm. So, the first example is the taxi algorithm. Step 1, go to the taxi stand. Step 2, get in a taxi. Step 3, give the driver my address. So, technically, you are just writing a couple of instructions on how to ride a taxi and go to a certain place. So, ganito kadali yung ating pagsusulat ng algorithm. Kailangan naiintindihan, simple, pero may finite number of steps at meron siyang outcome. So, for example, the call me algorithm. When your plane arrives, call my cell phone. Step 2, meet me outside the baggage claim. So, this is an algorithm for someone who's actually expecting a person who just arrived from the airport. And then, that person wanted to call you or to call him or her. So, next is the rent a car algorithm. Take the shuttle to the rental car place. Step 2, rent a car. And step 3, follow the directions on how that, follow the direction on how to go to the place of the person who rented the car, or follow the directions to get to my house. So, yun yung mga ilan sa mga sample algorithms natin. Now, paano naman po yung mga sample algorithms like for a simple programming problem? So, for example, you are going to design an algorithm to add two numbers and display the result. Most likely, kung kayo ay nagkaroon na ng experience in like C, Java programming, ilan to sa mga beginners or mga unang problems na naipresent sa inyo, unang examples na naipresent sa inyo. So, from before, you are not really asked to create an algorithm. May mga ilang pagkakataon na meron, lalo na sa computer science, because algorithm is very important to students who are studying computer science. Now, before you actually solve the problem, to write the code, ito muna yung algorithm on how to do it. No? So, for example, step 1, start. Step 2, declare 3 integers. So, sabi dito, add 2 numbers lang. Bakit meron 3 integers na dineclare? So, most probably, yung A and B is the first and second number, and the C integer is the container of the sum. Okay, so step 3, define values of A and B. Step 4, add values of A and B. Step 5, i-store mo daw yung output of your step 4 to letter C. So, and print letter C, then stop. So, meaning, my guess was correct. A and B is the container of the first two numbers, and the C is the container of the sum. So as you can see, by following these steps, you will be able to create an optimized programming code to your problem. So pwede mo na siyang i-apply to any programming language where you wanted to apply this problem. And then, well, you can actually create a different version of this algorithm by, katulad nito. Step 1, start add. Step 2, get values of A and B. Step 3, store the value of A and B to C, and then display C, and then stop. So, for this example problem, you can actually write a lot of algorithm versions. No, and usually the second method, the second method I have shown you is used to describe an algorithm. It makes it easy for the analyst to analyze the algorithm, ignoring all unwanted definitions. The programmer can actually observe what operations are being used and how the process is flowing. Now, if you know this, the step numbers, they're actually optional. Pwede mo yung tanggalin. But on my case, I will advise you guys as a beginner to write the step numbers. Kahit wala na yung word na step, kahit lagay nyo lang yung numerical number, 1, 2, 3, 4, 5, and so on, that's okay. Para laang mas madali nyong makita or mas madali nyong masundan kung ano ba yung step na ginagawa nyo. So that if you will refer to a previous step, you can just simply refer to the number of steps that you have written. So, sorry, I'll unzoom it. Okay, so in a nutshell, we design an algorithm to get a solution of a given problem. While a problem can be solved in more than one ways, we know that marami kang pwedeng maging solution. Maraming way kung paano mo gawa ng solution yung isang problem. Hence, many solution algorithms as well can be derived for a given problem. The next step for you is to actually analyze those proposed solution algorithms and then implement the best suitable solution. It's not all the time that the shortest steps of algorithms that has been created is the best solution. Hindi tayo nagpapaiksian dito o pahabaan ng solution. We are just simply going to analyze ano ba yung pinaka-acceptable solution dun sa mga na-draft out mo. Kung marami yan, parang meron kang nagawang, let's say, 5 algorithms, like 5 solutions to one problem, then analyze one by one kung ano ba yung most appropriate na gamitin. Um, in a real life scenario, you have to actually consider a couple of things. Yung resources, yung time frame, hanggang kailan ba dapat matapos yung problem na yan, mabigyan ng solution. So, yun ang ilan sa mga dapat mong i-consider, no? And since we are talking about that already, let's proceed to the next topic, which is the algorithm analysis. Okay, so the efficiency of your algorithm can be analyzed at two different stages. Well, before implementation and the after implementation. The priori analysis is actually the theoretical analysis of an algorithm. When we say theoretical, the efficiency of your algorithm is being measured by just assuming that all other factors, like for example, the processor speed, are constant and have no effect on the implementation. So, in theory, nag-create ka na ng analysis mo. For the posterior analysis, which is also known as the empirical analysis of the um, algorithm, with here, the selected algorithm is implemented using a programming language. So, tinetest mo na siya using a programming language. This is then executed on target computer machine. So, in this analysis, actual statistics like running time and space are actually collected. So, in a way, you are creating the priori and posterior analysis, which is the before and after implementation, para matest mo talaga kung yun yung nagiging outcome ng iyong algorithm ay makatotohanan, tama ba, and the most suitable algorithm for a certain problem. So, we shall learn about a priori algorithm analysis because um, algorithm analysis deals with the execution or running time of various operations involved. Now, the running time of an operation can be defined as the number of computer instructions executed per operation. So, hindi din natin naman pwedeng isa walang bahala to kasi it's just the priori analysis like planning pa lang ano ba ang magiging kalalabasan ng algorithm ko. So, dito parang nag-expect ka na ng mga possibilities na pwedeng mangyari once your algorithm has been implemented. The next thing that we will be talking about are the following: space complexity and the time complexity. Earlier on this discussion, I was able to tell you this keyword already. So let us go ahead and discuss this further. Space complexity of an algorithm represents the amount of memory space required by the algorithm in its life cycle. Well, we can say the space required by an algorithm is equal to the sum of the two following components, no, yung fixed part and the variable part. When we say fixed part, it is a space required to store certain data and variables that are actually independent of the size of the problem. So, for example, simple variables and constants used, program size, etc. Next, a variable part naman is a space required by variables whose size depends on the size of the problem. For example, dynamic memory allocation, recursion, stack space, etc. So, yun yung ating space complexity. Again, for the space complexity, the space required by an algorithm is required to the sum of the fixed part and the variable part. Next is the time complexity. This is actually the last topic that we will be discussing for our first lesson. So let me read this to you. The time complexity of an algorithm represents the amount of time required by the algorithm to run completion. The time requirements can be defined as a numerical function such as t of n, where t of n can be measured as the number of steps provided each step consumes constant time. So this is our equation. So for example, in the addition of two integers, yung kaninang example natin, no, ang problem natin is adding two numbers. It will take number of steps. Consequently, the total computation time is t of n is equals to c times n, where c, variable, is the time taken for the addition of the two numbers. So, hence, here we are going to observe that the time requirements grows linearly as the input size increases. So, parang they are parallel to each other when the time requirements grows daw kapag ka ang input size ay lumalaki din. So, yun po yung ating time complexity. So, this is actually the end of our discussion. To summarize, data structure is the study of various ways of organizing data in a computer. Data structure adds to our data and make the algorithms much simpler, easier to maintain, and often faster. Data is information processed or stored by a computer. The algorithms describe the way the data is to be transformed. Interface represents the set of operations that a data structure supports. An interface only provides the list of supported operations, type of parameters they can accept, and the return type of these operations. We have learned the implementation that implementation provides the internal representation of a data structure. We also learned that the implementation provides the definition of the algorithms used in the operations of the data structure. We also discussed that algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. And the algorithm writing is a process and is executed after the problem domain is well defined. That is, we should know the problem domain for which we are designing a solution. So that's it for our first lesson. For the references where I took this information from are from programming, tutorial boards, study tonight, Expert Geeks, and so on. Excuse me. So that's all for our first lesson. Thanks guys for listening.